All right, this is Advent of Code, day 25. Combo breaker. You finally reached the check-in desk. Unfortunately, their registration systems are currently offline and they cannot check you in. Noticing the look on your face, they quickly add that tech support is already on the way. They've even created all the room keys this morning. You can take yours now and give them room deposit once the registration comes back. Room key is a small RFID card. Your room is on the 25th floor and the elevators are temporarily out of service, so it takes a while. With little energy you have left to climb the stairs and navigate the halls, you finally reach the door to your room, swipe your card, and beep, the light turns red. Examine the card more closely, you discover a phone number for tech support. Can we help you today? You explain the situation. Card isn't sending the right command to unlock the door. If you go back to the check-in desk, someone can reset it for you. You describe the status of the elevator and the exact number of stairs you had to climb. I see. Well, the only other option is reverse engineer the handshake that the card does with the door and then inject your own commands, but that's definitely impossible. You know a thing or two about cryptographic handshakes. All right, so here are our inputs. Handshake used by the card and the door involves an operation that transforms a subject number. To transform the subject number, start with the value 1. Then a number of times called the loop size, perform the following steps. Set the value to itself multiplied by the subject number. Set the value, to int 1 equals ints. Called the loop size. Div equals 2020 1227. The card always uses specific secret loop size when it transforms the subject card. The door always uses different secret loop size. Handshake works like this. All right, so subject number 7. Okay. Def transform subject number loop size val equals 1 loop size dot times do val equals val times equals subject number val equals val mod div mod, I'll call that. Okay, so CPK equals transform 7 something, DPK equals transform 7 with door secret loop size, card secret loop size. The card and the door use the wireless RFID symbol to transmit the 2 public keys. Your puzzle input. Oh, shoot. The card and the door use the wireless RFID to transmit the 2 public keys. Your puzzle input to the other device. Now the card has this is card public key and this is door public key. Now the card encryption key equals transform door public key by card loop size and equals okay. If you can use the 2 public keys to determine each, calculate the secret encryption key that the door, okay. If you know that the card's public key is this, with a little trial and error, you can work out that the card's loop size must be 8, because transforming the initial subject of 7 with a loop size of 8. Okay, so what we need to do is equals 7, loops equals 0, while val equals 1, while val not equal that, loops plus equals 1, val equals that, val equals val mod So then card loop size equals loops, transform door public key card loop size puts 606205544. Nope. I should finish reading the instructions. You can use either device's loop size with the other device's public key to calculate the encryption key, transforming the subject key of 2020-1227. Card transforms the subject number of the door's public key, which is the second input, subject number You can use either device's loop key with the other. Put CLS. Eight. Oh. Eight. Let's transform the door public key which is that with a loop size of 8, produces the encryption key. Oh, I don't return val. $128. Oh, bummer. The light returns green and the door unlocks. Pay the deposit. Yeah, we did it. We did it. Dang. I could have done so much better if I just returned val. How did I do on part 2 though? 712. Okay, people figured out you click it to do part 2. $110. Dang it. You spend all 50 stars to cover the room deposit. As you fix the soft serve machine, Santa offers you a ride in his sleigh. Maybe the resort has a chimney you can use. Congratulations, you solved every puzzle. Hope you had as much fun solving them as I had making them for you. Supporting advent of code. I'll do that in a second. But let's go back to this problem. Yay. Whoa! What's going on there? That's intense. All right, day 25 combo breaker. You finally reach the check-in desk. Unfortunately, their registration systems are currently offline and they cannot check you in. Noticing the look on your face, they quickly add that tech support is already on the way. They even created all the room keys this morning. You can take yours up now and give them your room deposit once the registration system comes back online. The room key is a small RFID card. Your room is on the 25th floor and the elevators are also temporarily out of service, so it takes what little energy you have left to even climb the stairs and navigate the halls. You finally reach the door to your room. Swipe your card and beep, the light turns red. Bummer. Examining the card more closely, you discover a phone number for tech support. Hello, how can we help you today? You explain the situation. Well, it sounds like the card isn't sending the right command to unlock the door. If you go back to the check-in desk, surely someone there can reset it for you. Still catching your breath, you describe the status of the elevator and the exact number of stairs you just had to climb. I see. Well, your only other option would be to reverse engineer the cryptographic handshake the card does with the door, and then inject your own commands into the data stream, but that's definitely impossible. You thank them for your time. Unfortunately for the door, you know a thing or two about cryptographic handshakes. The handshake used by the card and the door involves an operation that transforms a subject number. So this is what I've written here. Transforms a subject number. To transform a subject number, start with the value 1. Then, a number of times called the loop size, perform the following steps. Set the value to itself multiplied by the subject number. Set the value to the remainder after dividing by the value 2020, 1217. So that's what we have there. And then critically, you need to return the value from this transform function. And that's what I forgot to do. And that cost me a lot of time. Bummer. So the cryptographic handshake works like this. The card transforms this. The card always uses a specific secret loop size when it transforms a subject number, and the door always uses a different secret loop size. The card transforms the subject number of 7 according to the card's secret loop size. The result is called the card's public key. The door does the same thing with its secret loop size, and that's called the door's public key. The card and the door use the wireless RFID signal to transmit the 2 public keys to the other device. That's our puzzle input. So we have the card public key is the first number, door public key is the second. Now the card has the door's public key and the door has the card's public key. You eavesdrops on the signal and you have those, but you don't have the loop size. The card transforms the subject number of the door's public key according to their own loop size. The result is the encryption key. The door transforms the subject number of the card's public key according to the door's loop size. The result is the same encryption key as the card calculated. If you can use the 2 public keys to determine each device's loop size, then you will have enough information to calculate the secret encryption key that the card and door use to communicate. This would let you send the unlock command directly to the door. For example, suppose that you know the card's public key is 5764801. With a little trial and error, you can work out that the card's loop size must be 8, because transforming the initial subject number of 7 with the loop size of 8 produces that number. So we have to basically reverse engineer the loop size for one of these. So we start with the card public key. So what is it called? Subject number is 7. We haven't done any loops yet, and our value starts at 1. And then while that val isn't equal to the public key, we increment how many loops we've done. We multiply the value by the subject number and then take the mod. That gives us the loops for the public. That gives us the loop number for the card key. Then we just need to transform the door's public key with the card's loop size to get the encryption key. So that's what we have here. Boom. Then for part 2, the light turns green and the door unlocks. You notice the brand written on the side of the lock, Diffie, Hellman, and Merkel. As you collapse onto the bed in your room, your pager goes off. It's an emergency, the elf calling you explains. The soft serve machine in the cafeteria on sub-basement 7 just failed, and you're the only one that knows how to fix it. We've already dispatched a reindeer to your location to pick you up. You hear the sound of hooves landing on your balcony. The reindeer carefully explores the contents of your room while you figure out how you're going to pay the 50 stars you owe the resort before you leave. Noticing that you look concerned, a reindeer wanders over to you. You see that it's carrying a small pouch. Sorry for the trouble, a note in the pouch reads. Sitting at the bottom of the pouch is a gold coin with a little picture of a starfish on it. Looks like you only needed 49 stars after all. If you like, you can check on your deposit, and that's how you complete part 2. Cool. So I'm going to commit this because there's actually a much simpler way to do this. Or not simpler. December 25th, 2020 solution. Push org. Oops. So the key thing here is we don't actually need to do two separate loops. We can, because as we're figuring out the loop size for the card public key, we can also be transforming the door public key. So we can actually get rid of this, and then we can have card subject number equals 7, door public key. I'm going to keep these variables. Then val1, val2 equals 1. We don't even need to keep track of how many loops we have. But we can also do val2 times equals door public key, val2 equals val2 mod val2. Oh. DPK. Oh. Boom. So that's a little bit shorter way of solving it. You can basically transform them at the same time. Yep. So that is, let's add that. Clean solution for December 25th, 2020. Cleaner. All right, so that is Advent of Code, day 25. Thank you very much, Eric Wastel, for a very enjoyable Advent of Code. I know certainly a month ago I was looking forward to it as a good way to end 2020, and it did not disappoint. So thank you very much, Eric Wastel. If you have not donated, you should. I'm about to. Yeah, thank you.